We're looking at inverse and joint variation. Now we're first going to review direct variation. That's from quite a while ago. With direct variation we had y equals k times x. And one thing we want to just kind of review is what happens to the y as our x values increase. Now remember, k is our constant of variation, so it's going to remain the same. So if you're not sure what's going to happen to your y, give yourself a situation. So let's say we had y equals 4x, and that was our variation. So ask yourself, if I were to leave x as 1, what would my y value be? Well, I would plug 1 in there, multiply it out, and I would get y to be equal to 4. Well, now as x increases, so I want something bigger than 1. Let's go with a 4. What happens to my y value? Well, 4 times 4 is 16. So as x increases, my y value increases. The reverse is also true. As x decreases, my y value decreases. That's for direct variation. Now our new one today is inverse variation, and it has the form y equals k over x. Now the way you would see this phrased would be y varies inversely with x, and again our k is the constant of variation, so it's going to be some number. Well, what's going to happen to y as x increases? So if you're looking at this and you're not real sure, give yourself a situation. Let's say we had y is equal to 10 divided by x. We can ask ourselves, what's going to happen to my y value as my x increases? So I'm going to start with x equals 1. Well, if I plug that in there, 10 divided by 1 is 10. Now I'm going to increase my x. I'm going to increase it to 5. 10 divided by 5 is 2. So look at what happened to my y values. As my x value increased, my y value decreased. That's where the term inverse comes from. So as x increases, y decreases. Now the reverse is also true. As y increases, x decreases. So they will always be opposite of each other. Okay, here's an example. All we're going to do is go through and decide, is this inverse variation or direct variation? Now you might want to jot down your two kind of generic formats. For inverse variation we have y equals k over x. Direct variation y equals k times x. So this first one, if you look at our setup, we have y equals 5x. Well, that looks identical to y equals kx. So this one would be direct. Okay, this next one. This one doesn't look quite right. I mean, there's division in it, but our format up here says y equals k over x, and this one has x equals y over 5. So one thing I'm going to recommend, when you're given these problems and it asks you for inverse or direct variation, you're going to want to solve it for y, because what's going to happen is these variation relationships can come in multiple forms. And what I mean by that is, if I were to tell you we have the fraction 1/2, how does that compare to the fraction 3 over 6, or how does that compare to 0.5? Well, all of these things are the exact same value, but they're just represented differently. They look different. Same thing can happen with our equations. They can look very different, but they can still have the same relationships. So when we solve this one for y, since it's divide by 5, I need to multiply both sides by 5, and I'm going to be left with y equals 5x. Now that we've got it into kind of our standard form, we've got y equals, we've got 5x, we've got direct variation again. So in the beginning it didn't look like direct variation at all. It actually looked more like inverse variation because of the division, but once you reformat it, it actually is direct variation. Third one, y equals x plus 7. Well, we've got y equals, so we don't have to rearrange it at all. And if we look back up here at our inverse variation, it doesn't look like that at all. It actually doesn't look like direct at all because there's a plus sign here. So this one is none. It doesn't follow either of those patterns. And the last one, we have x times y is equal to 18. Okay, again, it doesn't match either of our formats right now, but we don't have y by itself. So I'm going to go ahead and get y by itself, divide both sides by x, and I'm going to get y equals 18 over x. And as I look at my format, that matches this one exactly. My constant of variation, my number, is on the top, my variable's on the bottom, so this one is inverse. When you're doing these problems, make sure you write them as y equals because they can be tricky. Here's going to be our first practice one. It tells us x and y vary inversely. When y is equal to 8, x is equal to 5. Find the constant of variation, then write the inverse variation equation. Find x when y is equal to 35. So there's actually three different things going on here. We are going to start with this first one. Find the constant of variation. When you're given a problem like this, you want to seek out that key word right there. They vary inversely. As soon as you see inversely, y equals k over x needs to come flying to the front of your mind. We're going to start with that very generic setup. Y equals k over x. Then it tells me when y is 8, x is 5. Well, when I'm doing this inverse variation, I want x and y to be the letters x and y. I actually want k to be a number. Well, I can't just plug any number I want in there for k. I have to substitute this pair into my generic setup so I can solve it for k. So I'm going to end up with 8 is equal to k divided by 5. Solve that for k, and I get k is equal to 40. So the first part here said write the constant of variation, or find the constant of variation. Here's our constant of variation, k is equal to 40. Second part, write the inverse variation equation. Now we can take our constant of variation and plug it into our equation. So I have y equals 40 divided by x. That's the second part. Notice that x and y went back to x and y because this 8 and 5 was just one special case. It's kind of like having a table of values and you just pulled one particular value off that table to use to find our k. But there's an infinite number of x and y pairs that can go together. The third part here says find x when y is 35. Well, I've got my equation now, so I can just substitute that value in there. Since my y is the 35, I would have 35 equals 40 divided by x. I need to get x by itself. Well, since it's in the denominator, I have to get it out of the denominator first. So I am going to multiply both sides by x. So I would have 35x is equal to 40. Then I need to divide both sides by 35. I'm going to end up with 40 over 35, which will reduce down to 8 over 7. So there would be my three answers for that particular problem. Okay, for our joint variation, our definition says a quantity varies directly as the product of two or more other quantities. So that's how we get joint variation. Let's go back and tear this apart. So a quantity varies directly. So that means I'm kind of dealing with this y equals kx because we have direct variation. But then it says as the product. Well, product means to multiply. So we have the product of two or more other quantities. So instead of x, I have to have another variable here. Let's call it w for right now. And it says it could be more than two quantities. So maybe it's x times w times z times r. It could keep going. But the idea here is that we have a product. So we have kind of a direct variation setup where we have our constant times the number, as opposed to inverse, which is our constant divided by a number. But this doesn't have to be a single number anymore. It can be 2 or 3 or 4. Most of the time we will be dealing with the setup z equals k times xy. Now keep in mind the z and the x and the y can be actually any variables. The k will be the constant of variation again, which will be a number. Okay, so here's a second practice one. Does the data show direct variation, inverse variation, and how come I didn't put joint variation on this one? Well, joint variation has to have 3 variables because I have to have one variable varying jointly with 2 others. So that's actually 3 variables. This only has 2 variables. So now we're going to look at the table. How can I take a table and decide if I have direct variation or inverse variation? If we tackle direct variation first, that's our y equals k times x. Well, the constant of variation is called the constant of variation because it's constant. So what has to happen is for every xy pair I have to get the same k. Now the easier way to solve this is to isolate the k. So if I were to divide both sides by x, I would end up with y divided by x equals k. So what I need to do is pick each pair and plug it in. Okay, if I pick the first one, I would have 7 divided by 0 is equal to k. Ooh, that's going to cause us a problem because I have a 0 in the denominator. Let's try the next one. What if I were to do 11 divided by 2? Well, 11 divided by 2 is 5.5. So that would be a k there. Let me try the next one. If I were to do 19 divided by 6, I end up getting 3.16 repeating. You can actually stop right there because my k's did not match up at all. So does not show direct variation. Now we have to go back and check the inverse variation. So again, I'm going to start with my generic setup. Y equals k divided by x. Well, I'm going to isolate that k again. So I'm going to go ahead and multiply both sides by x. So I would have x times y is equal to k. Now I need to go through and check if my k is constant. Well, my first one, 0 times 7, gives me a 0 for my k. My second, 2 times 11, gives me a 22 for a k. You can check your third if you want, just to double check your math. 6 times the 19 is 114. So our k is not turning out constant at all, so it's not inverse variation. So for this particular one, we have neither again. Okay, I'll give you an example of a table of values that would show direct variation. Let's say I've got -2, 3, and 6. And then my y values, I'm going to have -8, 12, and 24. Now remember, my direct variation equation is y equals k times x. If I isolate my k again, I have to do y divided by x equals k. So I'm going to check each pair of these numbers. Well, if I take -8 divided by -2, I get 4. If I take my next pair of numbers, 12 and 3, 12 divided by 3 gives me 4. If I take my last pair of numbers, 24 divided by 6 gives me 4. So this situation, I got the same k for every single pair of numbers, so this one would show direct variation.